Are we aware of our daily routines? In the morning, we take our shower under hot water. We wash our dishes. We brush our teeth. Watering the garden. How beautiful and routine, isn't it? So will it always be like this? I regret to say that this will not happen. We will look for a glass of water a lot. What awaits us in this beautiful world? Water demand in the world is expected to increase by 55% until 2050. On the other hand, fresh water resources are gradually decreasing due to population growth and global warming. 70% of the world is covered with water, and the amount of this water is 1,386,000,000 cubic kilometers. Although this amount does not change, why does the water problem arise? Since 97% of this water is salt water, it is not suitable for human consumption. As both the world population and temperature increase, there is a problem of fresh water. 70% of fresh water is used in agriculture. Food production to feed the growing population will increase by 69% to 2030. In addition, water is used as a coolant in the production of electrical energy, and this energy is expected to increase by 20%. The city of Mexico City, which is built on old lake beds, is collapsing 22 centimeters a year in some areas. Because city water is drawn from the underground water basin. 40% of city water is imported. Authorities attribute the water problem to heavy rains, flooding and rapid flow, followed by long periods of drought. Similar developments are taking place in Drought, California. Between 2011 to 16, the region experienced the driest period of the last 1,200 years. Large underground watersheds decreased, 1,900 wells dried up. Some believe that water shortages will lead to wars. There are those who attribute the civil war in Syria to this cause. According to Dr. Peter Engelke of the Washington-based Atlantic Council, from 2007 to 10, Syria experienced the worst drought in its history, and hundreds of thousands of rural people were forced to migrate to the cities. All of which would predict a bleak future, but some nations have worked out solutions. And they are impressive ones that the rest of the world can learn from. For example, Australia survived its millennium drought from 1997 to 2009 by rapidly implementing measures that halve business and residential water use. Australia is the gold standard, says Richard Damania, global lead economist in the World Bank's water practice and formerly of the University of Adelaide. The key was putting a price on water and making it a tradable commodity. Another gold standard is Israel, which views water availability as a national security issue. By recycling effluent water, including household sewage, the Shaftan wastewater treatment facility near Tel Aviv supplies approximately 140 million cubic meters of water per year for agricultural use, covering 50,000 acres of irrigated land. Over 40% of Israel's agricultural water needs are now supplied by effluent water. The waste sludge is also sent to an anaerobic digestion plant, which uses the methane as a fuel to produce renewable energy. Even more mind-blowing? Israel's water treatment systems recapture 86% of the water that goes down the drain. The next best performer, Spain, recycles just 19%. So can the world simply desalinate its way out of the freshwater crisis? It's unlikely, says Damien. On average, it's about 5 to 7 times more expensive. The energy footprint is huge, and you've got to do something with the salt. If you look at aerial images around the coasts of Kuwait and Dubai, areas that are highly reliant on desalination, you'll see the havoc that is caused to marine ecosystems. Given the costs, both economic and ecologic, it is only a boutique solution in very rich places, he says. Coca-Cola 30 offshore factories cover the water load through treatment. However, she says that the people responsible for this field see their future with this method. A simpler and cheaper solution is rainwater capture. It's an old idea whose time may have come. Beneath Istanbul, Turkey, the basilica cistern built by Caesar Justinian can hold 80,000 cubic meters of rainwater. 1.5 millennia on, many cities are now emulating it. Manchester Metropolitan University's Burley campus, built in 2014 to house some 6,500 students and staff, aims to be entirely water self-sufficient through rainwater capture, wastewater recycling, and a borehole into the sandstone aquifer below. Rainwater is collected in a 20,000-litre tank below the building and is used for showering and toilet flushing. John Hindley, the university's assistant director of estates, explains, "This is about the sustainable use of resources. In October, we had storms that led to a lot of flooding. The university was flooded in several different buildings. These aren't just one-offs anymore, so having more sustainable systems not just in consumption, but slowing down runoff, capturing it, taking pressure off the system, is becoming of increasing importance to the university and to businesses in the city." The Burley campus water bill is 60% lower than if using water from mains. In most places around the world, the agriculture, irrigation techniques are pretty inefficient, says Engelke. Very efficient irrigation techniques do exist. Thermal power sources, nuclear, coal, natural gas, require vast amounts of water for cooling. Renewables, for the most part, solar and wind, do not. It all has to do with policies to encourage, incentivize, and invest. If we want to become water-efficient societies, there are ways in which we can do it, concludes Engelke. Either through increasing the efficiency with which every drop of water is used, or simply shifting away from water-intensive uses altogether. Whichever effective model of conserving fresh water we come up with, we need to come up with one, and sooner rather than later.